The process starts with the design phase, where engineers create blueprints and specifications for the hand pressure sealing machine, focusing on functionality and ergonomics. High-quality materials such as stainless steel, aluminum, and durable plastics are selected for different parts of the machine to ensure durability and performance. Individual components like the base, handle, sealing jaws, and heating elements are manufactured separately, often through processes like machining, casting, and injection molding. Components that require high precision, such as sealing jaws, are machined using CNC machines to achieve the required accuracy. Metal parts undergo heat treatment processes such as annealing or hardening to enhance their mechanical properties and longevity. Components are often polished, coated, or anodized to improve aesthetics, corrosion resistance, and wear resistance. Smaller subassemblies, like the heating unit or pressure mechanism, are assembled separately before being integrated into the main machine. Each component and subassembly undergoes rigorous quality control checks to ensure they meet specified tolerances and standards. The main assembly process involves combining all subassemblies and components into the final machine structure. For machines with electronic controls, wiring, and electronic components are installed and tested to ensure proper functionality. The sealing pressure and temperature settings are calibrated to ensure the machine performs effectively and consistently. The assembled machine undergoes extensive testing, including sealing tests with different materials to verify performance under various conditions. Safety mechanisms, such as overheat protection and emergency shutoff, are tested to ensure user safety. Fine adjustments are made to the machine to optimize performance, ensuring it meets all operational specifications. The machine is cleaned, inspected for any final defects, and then carefully packaged to protect it during shipping. Instruction manuals, warranty cards, and safety guidelines are prepared and included with the packaged machine. For efficiency, machines are often produced in batches, with each step of the production process being completed for one batch before moving on to the next. Parts of the production process may be automated, such as CNC machining and robotic assembly, to improve precision and efficiency. Some machines are customized according to specific customer requirements, involving additional steps like custom programming or part modification. Components and raw materials are managed in inventory systems to ensure a steady supply and minimize production delays. Close coordination with suppliers ensures the timely delivery of high-quality materials and components needed for production. Lean manufacturing principles may be applied to minimize waste and enhance efficiency throughout the production process. Workers are trained on specific tasks within the production process to ensure high standards of workmanship and safety. Efforts are made to reduce the environmental impact of the production process, such as recycling scrap materials and minimizing energy consumption.